Welcome and thanks for joining us. My guest today is Jay Meil, Jay, the Chief Data Scientist and Managing Director for Artificial Intelligence at SAIC. Jay, good to have you with us.
Thanks for having me here. I appreciate it.
And by golly, we are timely because everybody is talking about artificial intelligence these days. It's headlining almost every conference and every event. But more than that, it's actually becoming a reality. And not just generative, which is really famous, but all forms of artificial intelligence. And so what I'd like to get from you to begin is, what demand signals are you getting across the federal government? What is it they really want to do with AI, beyond the big overview buzzwords?
Yeah, so it's a great question, and I also thank you for not starting with a question on ChatGPT-3, because I think we've got enough of those, which talking about generative AI. Really, I would say that we have to first look at what AI is before we can talk about where those demand signals come from. So I think we have to separate artificial intelligence from its buzzword, right? So everybody says artificial intelligence, machine learning. The first thing I ask, our mission partners and our customers in the federal government is, what are you trying to do? Because AI is really just a means to an end. So are you trying to get automation? Are you trying to work with language models like we're seeing in the press today? Are you trying to work with images? Are you trying to fuse different types of data? Are you trying to make decisions based on a lot of different data? I think the key here is to really first establish what you're trying to do with it. And believe it or not, that tends to be a harder problem than it should be. Mm-hmm. Very often people say, the demand signal starts out as, I want artificial intelligence. And then you ask, what are you trying to do with it? You say, I don't know, but it's been mandated that I start using it. And so you really have to dig into and understand what the customer's mission is and sort of reverse engineer how artificial intelligence is going to help that mission. Very often the first question is artificial intelligence the right answer? Sometimes it's not. It's just, that's what people are thinking of right now. And so the demand signals are coming government-wide from the Department of Defense, federal civilian agencies, law enforcement agencies, the intelligence community, for different ways to start creating human-machine teams and for different ways to ease the cognitive load on users and to make informed decisions faster and better.
Yeah, that cognitive load is really much talked about these days because there are so many digital media in which people have to work on a given day. It used to be multiple screens, it still is. It's multiple browser windows now. And so that is part of that cognitive load. The online meetings, the texts and the chats, and there's sometimes 3 or 4 messages generated by project management systems. I mean, you don't know where you heard something or where you learned something, and sometimes you can't find it again. That's cognitive load.
Yes, sir.
All right. And then the human-machine teams, what does that mean exactly?
So I think it's about using, so humans and machines can both think in different ways. Machines think in a way that's very good at processing numbers very quickly, large amounts of data, pulling out what we would say is signals in the noise or hidden patterns or a needle in the haystack. Humans can do the strategic thinking, they can do the logical reasoning. And so you can't have one replace the other, which we always hear people talking about, is AI going to replace the human? I think the answer is no, but it retasks the human. So I work across, law enforcement, federal civilian agencies, Department of Defense organizations. Mm-hmm. Everyone in our daily lives and in our work lives is deluged with data. And you can almost get to this point of, analysis paralysis, or this point where there's almost too much data to even sift through. You can be the best analyst, you can be, the best enterprise, systems director, whatever it might be, and it's very hard to be able to see those signals through that noise. So when we talk human-machine teaming, we talk about enabling the machines to do what they do best and enabling the humans to do what they do best, and bringing that together to make better decisions faster.
So in many ways, the human-machine teaming idea is related to the cognitive overload.
Absolutely.
Because if you have a data overload, then there's more than you can make, like as you say, that paralysis by analysis.
Absolutely.
And so the AI can help you get to, and that leads to better decisions. The third area you mentioned.
Yes.
All right. And it strikes me that then the best way for agencies to actually use AI, to leverage it, to use the modern parlance, is you almost have to start at the lowest level in an organization, the unit doing units of work, more so maybe than the high-level thinkers and managers and secretaries and appointees?
Yeah, so I think there's two ways to look at it. I think there's the hierarchical level within the organization and how it might be used. But there's also the level of maturity that the agency has in their data and in their management already. So we have we call it the 5 sites. And it's sort of a different way to look at where you are on a maturity level for artificial intelligence and for data analytics. So we say, back to that original question, what are we using AI for? We say here are the things that AI can do, and it happens to be that maturity model as well. So we have hindsight, which is really descriptive analytics, right? That's sort of the first level of maturity. I have data, I can take that data, and I can understand what happened. It tells me a story about what happened. The next level of maturity and the next step up is foresight, right? So now I've got prior data, I can build some kind of a model, and I can understand what might happen. So this is predictive analytics. What could happen, outcome A, outcome B, outcome C, and a given level of confidence of those happening. The next level of maturity is insight, and that is prescriptive analytics. And when we talk about prescriptive analytics, it's if I know that I could have outcome A, B, or C with a given level of confidence, what can I do to drive towards one of those potential outcomes? And then from there, we have 2 that sort of work, we call it tipping and queuing, and these are oversight and right sight. So oversight is the ability to see everything, sort of in a common picture. So all of your analytics in one place on one dashboard, very often giving someone the ability to do self-service analytics on their own and understanding the world around them or the environment around them or whatever it is they're doing from sort of a holistic level. And then we have what we call right sight, which is individual deep learning or machine learning metrics that allow you to drill down onto things that you've been tip and cued to on that oversight. So for example, if I have a system dashboard and I'm watching, I don't know, let's say computer logs or something like that, my oversight might tell me that there's an anomaly present. So now we're going back to what the AI or the machine does best, right? Which is finding a signal in the noise or finding a needle in the haystack. That tips and cues the human. And so now the human is able to make a determination on that. Before they do that, they might need to do more research. They might need to do more analytics. And that's where that on-demand, deeper machine learning would come into play to help them make a decision.
Yeah, so there's really, it's almost a circle, these 5 sites, because the hindsight can feed the foresight because you develop a history, and therefore what is anomalous and what is something to be looked at gets smarter and smarter over time.
That's absolutely right. And the ability to have, and I'm really glad you asked that question, because a lot of times we focus on what the data looks like when we bring it in, how we shape it, what the model looks like, and what the results are. But most people forget about that last phase, which is what we call verification and feedback. So we know what our results are, but now we take it a step further and say, is that what we were expecting? Is that what the model should have inferenced? Is that what the answers should have been given? And then feeding that back into, you're right, the beginning of that cycle, so the models get smarter over time.
And I wanted to ask you about something that underlies all of this, and that is the data. And I think in the early days of AI, people presume, well, the bigger the data set, the better you can train. But what I think people learned is that if the data set is biased in some manner, the bigger the data set, the worse the training will be. So it's, how do you prepare your data? How do you pull the right data? And it's not necessarily big data required, is it?
No, not necessarily big data required. There are ways around that today, using synthetic data and using specific ways to train around sort of sparse data sets. But I want to address data sort of at the center of this. We all focus on the artificial intelligence and the machine learning, but we can't do that until we shift left and solve the problem with the data. So where I find a lot of our mission partners is that they're still struggling with the data. And what I mean by that is, how do we get different disparate source systems of data together in one place? How do we make sure that that data is coming in an appropriate and acceptable format to a particular system? How we label that data is another big one. Most data is unstructured. About 80% of data now is unstructured. Right. So what I mean by that is, when you think about audio, video, imagery, full motion, and even anything that we take for granted every day on our computer, like PDFs, PowerPoints, that's all unstructured data. And unstructured data needs to be ingested and put in a format that it can then be read into a machine to do artificial intelligence. And that requires segmentation and labeling and conditioning of the data. So the data is probably the biggest piece to this. We have to get the data right before we can do the artificial intelligence.
And within the field of unstructured, some of that is not even machine readable. You have to do some conversion like PDFs. I think a lot of agencies are learning how to take handwriting and this kind of thing and turn it into machine readable. Whereas audiovisual is a machine format, but maybe not the same as other data coming into the AI.
Yeah, so you need robust pre-processing pipelines. So when we talk things like PDFs, PowerPoints, SharePoints, documents of that nature, we need to do something called optical character recognition, where we can ingest that information and the computer can read that text or read that document, and it digitizes it into something that the computer can understand. When we talk about audio visual, it's also pre-processing. And it's the ability to make sure that we can get that format into a data format that the computers can understand as well.
So that's what you mean by good data.
That's what we mean by good data.
But can a given algorithm handle more than one data type, or does it need to be fed everything that's kind of been homogenized into what that algorithm or that AI program likes?
So it's a great question. Generally, algorithms need to have a certain type of data that they are fed to them. There are ways in that pre-processing pipeline to put data into a format that the algorithms can understand and inference on.
Right, so if you're making out of your AI Hershey Kisses, you can't throw butter and flour and cocoa in. That has to be done early in what comes out as chocolate, and then you shape it.
That's correct.
Maybe not the best analogy in the world, but I think it works. Okay. And so just to drill down on that one point then, agencies really have a pre-job before they jump into any AI, and that is really the data domain, the data officers, the data scientists, and the IT staff.
Absolutely. We deal with, as I mentioned before, almost an immeasurable amount of data at this point, a ubiquitous amount coming at us constantly from all different directions. And so agencies are capturing a significant portion of that data. But if that data is not curated properly, if it's not labeled properly, if there's no intent behind it in some cases, why you're bringing that data in and that's not being recorded, and if it's not cleaned properly, you can't do the machine learning and you can't do the artificial intelligence. It's the old adage, garbage in, garbage out.
Sure.
So you really need to focus on your data strategy and then feed that and let that lead into your analytics and artificial intelligence strategy.
So you really need a data factory almost that customizes the data sources for the particular application, because every application will need different data. So it's incumbent upon the user to understand what data sets they need, and then it's incumbent upon this data factory, to my word, to kind of prepare and position the data so that what comes out of that factory is suitable for that application and that algorithm.
Absolutely, and I think that's where sort of the value of SAIC comes in. Large systems integrator, we've been working with data and software for a very long time. We realized from a data science perspective that this is hard work. And it needs to be done right in order to get the results that you need.
So to sum it all up, how can agency leadership move forward with AI with some confidence and some idea of assurance that they're going to get where they need to be?
Yeah, so great question. Let's talk about confidence from two perspectives. So first of all, how can I be confident I have what I need to build machine learning and impactful analytics? Because in the end, it has to be impactful or there's no reason to do it. So it's really walking through a robust data strategy, making sure the data is labeled, and then building appropriate algorithms and being able to understand how the machines are making the decisions that they're making. So there's a lot of talk right now about responsible artificial intelligence, trust in artificial intelligence, giving up some of the tasks that humans would take to artificial intelligence. And so I mentioned SAIC's Tenjin, which is our low-code, no-code orchestration tool set for artificial intelligence. One of the ways that I think our federal partners can move ahead in AI is using a system like Tenjin. I'll tell you why. I mentioned AI is really complicated, and the data management part is also complicated. Mm-hmm. Data scientists, data engineers, there's a finite resource out there. And they don't also necessarily understand the subject matter or the domain knowledge of the particular agency that they would be working with. What Tenjin is designed to do very deliberately is give our customers the power to do data science. It empowers them, the analyst, the operator, the warfighter, the law enforcement officer, the diplomat, and any enterprise user to be able to interact with data in a fundamentally different way. And it creates self-service analytics. I call it federated data science, or making everyone a civilian data scientist or a citizen data scientist. And we do that by using a point-and-click, drag-and-drop interface that is really intuitive and not intimidating. And we also create a lot of traceability and auditability and explainability around everything that's being done. So you asked in your initial question, how am I confident that I can build artificial intelligence? And I would also say, how am I confident that my artificial intelligence is giving me the right answers? These are the ways that we do that, by having an explainable system. You hear a lot about black box AI, black box artificial intelligence. I'm going to give you an answer, but I can't explain how I'm giving that answer. And I believe that's not good enough for our customers. They need to understand how the decisions are being made. That leads to that trust and that responsibility around artificial intelligence.
Well, in the public sector, they have almost probably a statutory obligation in some cases to be able to explain how it was made. And we hear this explainable AI, expression has kind of come into this, and I heard it as auditable a number of years ago from the Defense Department, because if an autonomous system fires and kills somebody or destroys something, there needs to be an auditable decision rollback as to how that happened, because that's just what they need to do. What form does explainability take? I mean, it's not like the machine says, well, I decided if this is the case and that, or maybe it does. Maybe, does it talk to you?
So if you think about explainability in a life cycle of its own, there is a portion of explainability that's sort of behind the veil. And we say that it's inside the neural network that's actually making the decisions. We don't understand from layer to layer how a decision is being made. There are some ideas about mathematically how that works, but no one actually has been able to peel that back and understand it. The best that we can do is take the decision and sort of use invertibility to understand how it got there. And one of the things that Tenjin does, because again, mathematically that can be difficult, is we abstract it to a visual level for our users to understand, I say, from ingest to inference on data, how that's happening. So in other words, I have a visual flow that shows me all of my source data sets, how those data sets were ingested, how they were cleaned and organized, how they were enriched, what model they went into, how that model performed against other models, and then how I got to a decision. So we're getting closer to understanding how the machine is making decisions, but in the meantime, we have an ability to understand lots of different dynamics and aspects of how it's making the decisions.
Yes, because so many situations would require that. For example, in so many of the adjudication processes that someone in the government might have, and a decision might be made and it would have to be reviewed if you're going to accept the machine decision, for example, or in the DOD, as we mentioned a moment ago, the case of firings, an actual kinetic event caused by a decision from artificial intelligence. And can that be recorded and somehow fed back into the system such that it can improve?
Yeah, so right now we talk a lot about artificial intelligence systems and improving them by using human in the loop or human on the loop strategies or systems, where you either have a human who's going to affect the final decision, whatever that decision might be, or a human on the loop that's reviewing the final decision. I think to your DoD example, they're not quite to the point of autonomous systems pulling a trigger or enacting a particular effect, but you can test that and you can measure it against what a human would do. Now, in other cases, like we work with Department of Homeland Security and other federal agencies, and we're doing inference off of images and documents to speed up adjudication processes. When you said adjudication, that made me think about that. So the ability to take a process that might cause a citizen to go through and wait 180 days because there's a lot of paperwork involved and unstructured data involved and the inability to search electronically on that data, and be able to augment and use artificial intelligence to take images of that data, classify that data as to what it is, tie it out to a particular case, it might reduce that by 60 or 70% in terms of time frame. But even then, you want human feedback to tell the machine, yes, that is that document. So for example, if it's looking at a birth certificate and it says this is a birth certificate and here's all the information on it, you want a human to tell the machine, good job, right?
Sure.
We talk about that as reinforcement learning, and that helps reinforce the models. They say it's like a carrot or a stick approach to how the machines work. And that's a very important piece to how we train artificial intelligence models as well.
Because also in the acquisition domain, there's 210 possible clauses or something like that in a given federal contract. Not every contract needs every clause, but you need the clauses you need legally. And you know what can happen if a contract, is found not to be legally supportable. And a lot of people are looking at AI to generate contracts with only the right clauses, speed things up, make contracts shorter, and so forth. But that would be another case where you would need to be able to justify why one clause was in there and one was not.
Absolutely. And natural language processing, which is what you're speaking to, a particular subset of deep learning, all about text analytics, comes into play. And that's very much on the forefront right now of what we're doing. Natural language processing takes all of that, the words, the characters, the text, and the context behind them, and does that language generation that you're talking about, or even understanding, natural language understanding. So think about the ability.
But it also has to have the FAR in there, maybe, or something.
Absolutely. All of that, it has to be trained on all of that. And in order to make, it goes back to data, right? You have to have the right data to train the models in order to get the right outputs. If the AI model has never seen the FAR or ingested it, it could be the greatest model in the world and it's not going to give you the correct answer.
Sure. And that leads to another question, which is kind of a practical nature, but it comes up, and that is, how do you extract data that might be from different classification levels and feed them in safely into an artificial intelligence algorithm and still preserve the need for secrecy, if that's the case, or whatever the classification level calls for?
Yeah, it's a really good question. So that speaks to the problem, whether we're talking classifications or not, that speaks to the problem of data silos. So very often we have lots of different data owners, different data stewards, different agencies, different systems, different organizations, and people are not so readily available to share their data with others. And so what you very often have is, as you're trying to train a robust machine learning model, you're training it with blinders on because it doesn't have access to all of the data. So one of the things we had to do for our intelligence community customers and our Department of Defense customers and some of the other federal agencies that deal with sensitive data, think things like financial data or PII, personally identifying information, we needed to find a way to be able to extract that data and bring it into one essentially physically co-located space before we could train models. So we do that two ways. We have a technology called the Coverse Data Platform. That technology was actually developed out of the intelligence community years ago, post 9/11, the ability to bring all sorts of types of data together and tag it at a very fine-grained level. And what I mean by that is every data object is going to have a tag on it that might say this is secret data and only US citizens can look at it. Or it might say something like this is PII and financial data and only those with the allowability to see that information can see that information. So Coverse is a big part of that. The other piece to that is sometimes we have people who don't want to have their data ingested into a particular system, and we need to go out and just get or access data from those systems. And so we're using something that we call encrypted query, analytics, and data retrieval. That's a long word. And we developed it for some of our classified customers so that they can move data between point A and point B, or wherever they might need to do in order to build models, in a way that is protected in three different ways. So it's protected, the data is protected at rest, cryptographically through Coverse, protected in transit, and then it's protected in use. And what we mean by in use is we're using something called homomorphic encryption with a strategic partner of ours. And homomorphic encryption allows you to run calculations and run analytics on data without ever having to decrypt it. So you get a round trip, fully encrypted 3 ways. And that is allowing us, it's opening up a lot of doors in DoD and in the intelligence community and in sensitive federal civilian agencies to be able to automate more and do more artificial intelligence because of these technologies.
Yeah, that's been something sought out for a long time, that homomorphic, which you could do, but you didn't want it to take 27 years to do the process. So you can do it fast, you're saying.
That's right, yeah. Multi-level security and homomorphic encryption have been elusive for years, and now the technology is there.
Yeah, because this is something else you hear too that federal people are worried about is especially with cloud-hosted commercial AI applications, and I'm presuming that's what Tenjin is. Well, I don't want to just willy-nilly send my data up to someone like I heard mentioned specifically the ChatGPT. I don't know what's going to happen to it, but this sounds like a way you can assure people that it will stay encrypted and within a domain or an enclave that they can feel comfortable with from a federal standpoint.
Yeah, that's absolutely right. So great question. So Tenjin, real quick, Tenjin can be cloud-based and is often cloud-based. It can also be done on premises, and it can even be in air-gapped enclaves just because of the nature of the work that we're doing. But its deployment is interoperable in any way.
So it can be an edge facility also.
It can actually be an edge device as well, and we've proven that out with the Department of Defense. We can take it out on a laptop and run it in a completely disconnected environment. So to answer your question about not sending data into a space where maybe it's not protected, it's really about building models within the boundaries of the organizations that we're working with and using the lessons learned in the commercial space, bringing those technologies into the federal space, testing them robustly with a trusted partner like SAIC, and then containerizing them and deploying them on federal networks so that it's protected and it's using the technologies that may have been developed elsewhere, but now it's only working on the data that's inside the federal boundaries.
All right, we'll have to leave it right there. No excuses for not getting started.
Thank you very much.
All right. My guest has been Jay Meil, Jay, the Chief Data Scientist and Managing Director for Artificial Intelligence at SAIC. I'm Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search SAIC.